Okay, now this is your lecture number 2, the next short video. So just to make sure that you're not confused, I'm putting this in the beginning so that you can easily identify the lecture. So what we went through in the last short video was linked list structure. So this is how a linked list looks like. What we are going to do now is to see how we are actually going to create a node like this so that you can visualize in terms of see what we are talking about. So it's not just like a drawing on the paper. So you have gone through structures and you've gone through self-referential structures. So this is one self-referential structure that I've created here. The name of the structure is linked list. The linked list has just one integer as its data. The linked list in itself can have anything inside it which comprises the data it can hold. But for simplicity in our programming, since we are just beginning in data structures, we are just declaring the data as an integer, just to keep it simple. The next node in our linked list is a pointer. Now, what kind of pointer is it? It is a pointer to a node of the same structure. So before we are even finishing the definition of our structure, we are putting a pointer of the same structure type within the data, within the definition of the structure. And that's why these structures are known as self-referential. They have a pointer inside which point to themselves, in the sense to a node of similar kind. So what we are doing is we are defining a structure called linked list, and we are also declaring a pointer which is called start for now. So what I generally do in my programs is that instead of writing struct linked list and then defining the variables of the type linked list, I just use a type def definition, type def struct linked list SLL, singly linked list, because we are just talking about one pointer in the linked list. Then I can use SLL and then declare my pointers. Okay. So by doing this, I have not yet created a node for a linked list. I have just defined the structure of the node. Okay. And what is this? This is not a node. It is a pointer of type linked list. So you have to understand the difference between a structure variable and a structure pointer. When I create a structure like this, the structure variable, when I say SLL, if I just say X is a variable of type structure singly linked list. X will look like this, data and next field. But when I say when I say pointer start, it can just hold an address of a node of this type. Okay. So when you have a variable, for example, you can have if I add a variable X here. When I say X, for X, a memory location like this is reserved, which can hold data and which can hold a pointer of similar type. But when I say star or star temp, it can hold the address of this node, but it will not have the memory to hold a data and an address. It is just a pointer holding the address. Okay, just like when you say int X means there is a memory location X that can hold an integer. But when I say int star Y cannot hold an integer, Y can hold the address of a integer location. Okay, so when I define a structure X, in the memory, something like this will be reserved for me. So data and next. Data can hold an integer according to our definition, and next holds address of the next node. Okay. Now, let's start creating the linked list. We have to write a full program for this, but let's do it step by step. So when you have to create a linked list, you do not define anything in the beginning other than your structure definition and your start pointer. So I've already defined my start pointer. Initially, I should ideally assign it to null. I have not done it here, but once we do the programming, we will define it as null. Okay, so let's say we have to add a node, the first node in the linked list. So how do we do that? So to add a node, we actually need data for the node. So we'll use a scanf statement in our program to get the data. And let's say I got that. After that, I just have a start pointer. What I'll do is I have to allocate memory for one node, because that is the request that has come to me. So I'll use dynamic memory allocation for one node. Okay. And how do I do that? Okay. So malloc is used for dynamic memory allocation, as I've already asked you to go through that. I use size of simply linked list, so that the size of the structure that I've defined in my program, that is calculated, and that much block of memory is allocated. And malloc, it returns the pointer to a particular type or particular size of block of memory. So I want this pointer to be of type singly linked list, because I need to access elements within. So it's always a good thing to typecast the pointer to the type you want. If it was an integer, I would have written int star. So I'll typecast and I'll put that whatever the system returns to me in terms of the pointer into temp. Now temp I had defined as a pointer to the structure singly linked list. So it can hold the address of a node of type singly linked list. Okay. So now temp has the address of whatever block of memory the system returned. And now I need to put the data inside this. Okay. So this is what I do next. I assign the data, let's say it was 50, into the data field, and then since this is the only node in the linked list, there is nothing after this in the linked list as of now, so I will assign null. We say we ground the linked list, so the chain ends there. And now this is temp is a pointer. It holds the address of the first node. The address of the first node should be in start, because this will help us to basically access our linked list. So I'm putting this address in start, and what I get is this kind of structure in memory where you have 50 as data and you have null in the next field, and this address was actually in temp. Let's say the address was 2000, so that 2000 is in temp. Now I have copied that 2000 to start, and start is one variable that you have to take care of, as I mentioned earlier, because this is basically the key to the door of the linked list. So if you lose this, you lose your entire linked list. Let's say it has 100 nodes. If you somehow overwrite your start pointer, you lose access to the entire linked list. So you have to always make sure that you preserve your start pointer. And another thing is that when you write a program, it depends on you how you define your start pointer. What I mean by that is, let's say if my start pointer is global, so when I have to use the start pointer to access my linked list, I can access it from any function that I write. But if it's not a global pointer, then I have to pass the value of start pointer. And in some cases, maybe in the functions, I need to modify the start pointer, in which case I should be able to do that permanently, is in the sense, then you need to make sure that either you return the new updated value of start to the main function, or you pass the address of start so that you can modify start. You'll see more of this later once we come to the actual programs. So now if you look at the linked list that we had mentioned earlier, so if 9 was our first element, this is all that we would have, and this would point to nothing. So this would be your current linked list. Nothing else will be there. Okay. So as you go on adding, you will create your linked list. Okay. So in the next short video, I'll show you how we are going to do additions and deletions and insertions in our linked list. First, we'll do that pictorially so that you can see how it actually takes place, and you will also learn how you are actually just manipulating the pointers here and there to do additions and deletions. Okay, so I'll do that in the next video.